A network of 4 20 microfarad capacitors is connected to a 600 volt supply as shown in figure. The equivalent capacitance of the network is. So here you can see that this is a network of 4 capacitors, and the capacitors C1, C2 and C3. These three are connected in series as they are connected in a single branch. Clear? And C4 is in parallel with the equivalent capacitance of all these three. So that means here in this particular case, the equivalent capacitance of all the three capacitors, that means C1, C2 and C3. Here C1, C2 and C3 are in series. If they are in series, then their equivalent capacitance will be 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So that means here in this particular case, as all the capacitors are having equal capacitance, that means it will be 1 by C plus 1 by C plus 1 by C. So it will be equal to 3 by C. That means CS will be equal to C by 3, or it will be nothing but 20 by 3 microfarad. So that means equivalent capacitance of all the three capacitors is how much? It is coming out with 20 by 3 microfarad. And this C4 will be in parallel with CS. That means here in this particular case, if we just look at the combination over here, so assume that this is CS and C4 capacitor will be in parallel with all this. That means this will be C4. So here, and this system is connected to the 600 volt supply. So that means as these two are connected in parallel, so that means their equivalent capacitance will be nothing but CS plus C4. And CS, what we got right now, it is 20 by 3 plus C4. C4 it will be that is 20, because each capacitor is of 20 microfarad. So finally the result will be, so if we will take LCM, so it will be 3. So it is 20 plus 60, that will be 80. So it will be 80 by 3 microfarad, or approximately if we do the calculation, if we divide that one, so it will be coming out to be 3 to the 6. So finally it will be 2 and 20, so 3 6 18, so 6, so 26.66 something like we will get 20 microfarad capacitance. So approximately how much we'll get? 30 wrong, 20 wrong, so 26.67 it is given. So approximately we'll get like, that means 26.67 microfarad will be the equivalent capacitance of the given combination. In the question number 66, the charge on capacitors C1 and C4 are. So here in the previous question, if we just look at the figure, so what was given in the previous question is that all the capacitors are of 20 microfarad each. Clear? And we got the equivalent capacitance. So here C1, C2 and C3 are in series, and their equivalent capacitance, how much we got? Their equivalent capacitance we got 20 by 3 microfarad. Clear? And that is connected in parallel with the C4 capacitor. That is connected in parallel with the C4 capacitor, and its capacitance is 20 microfarad. And the potential difference across the both is maintained at 600 volt. तो ये जो दो कैपेसिटर है, दोनों के अक्रॉस पोटेंशियल डिफरेंस यहाँ पे कितना होगा? एज दे आर कनेक्टेड इन पैरेलल, दैट मींस पोटेंशियल डिफरेंस अक्रॉस 20 माइक्रोफैराड विल बी 600 volt, and potential difference across the 20 by 3 microfarad capacitor will be same 600 volts. So that means charge across this 20 by 3 microfarad capacitor, charge across here. So charge Q, let it be, it will be how much? It will be Q is equal to C into V. This is the formula that we will apply. So C is 20 by 3 microfarad, that means into 10 to the power minus 6, and potential difference is 600. So how much will you getting? So 3 to the 600. So finally 3, so here 3 to the 6. So here 2 into 2, that is 4 into 10 to the 3. 4 into 10 to the power 3 into 10 to the power minus 6. So how much we will get? We will get 4 into 10 to the power minus 3. So this much coulomb. So charge on this upper capacitor will be 4 into 10 to the minus 3 coulomb. So here in this particular case, edge all the three C1, C2, C3 whose equivalent capacitance is 20 by 3 microfarad, and all these are connected in series. So we know that in series combination charge remains same. In series combination charge remains same. That means here also charge, here in C1, C2 and C3. So here in charge across C1 will be equal to charge across C2 and will be equal to charge across C3. That means here if charge is Q1, here if charge is Q2, and here if charge is Q3, then charges will be how much? Simply 4 into 10 to the power minus 3 coulomb. And across the capacitor C4, assume that the charge be Q4. So if the charge is Q4, so here this is a 20 microfarad, this one, clear? So that means charge across the C4 capacitor will be simply C4 into potential difference. So C4 is how much? C4 is 20 into 10 to the power minus 6 and into potential difference is 600. So finally how much will be getting? 12. So it should be 12 into 10 to the 3 into 10 to the minus 6. So it will be 12 into 10 to the power minus 3 coulomb. So that means across the Q4, across the C4 capacitor, the charge will be how much? 12 into 10 to the minus 3 coulomb. So we can check the options over here. So here first one is 4 into 10 to the minus 3. Okay, C1 here it is asking the charge on C1 only, clear? So C1 में कितना है? 4 into 10 to the minus 3. Okay, that is correct. And C4 में यहाँ पे कितना होगा? 12 into 10 to the minus 3. So option A is the correct. 6, the 12 wrong, 2, 4 wrong, 3, 2 wrong. So that means these three options will not be valid. The charge on 3 microfarad capacitor shown in the figure is, the options are 2 microcoulomb, 10 microcoulomb, 6 microcoulomb and 8 microcoulomb. So here in this particular case, if you just look at the figure, so these three capacitors are connected in series. So here this is a series combination. So as this is a series combination, so here in this particular case, the charge across all the capacitors will be same. But how to find out the charge across all the capacitors? So before that one, what we need to find out, we need to calculate the equivalent capacitance of the series combination. So equivalent capacitance in this particular case will be how much? Simply 1 by so it will be assume this one as capacitor C1, this is C2 and it is C3. So 1 by C1 plus 1 by C2 plus 1 by C3. So this is the formula that we have to apply over here. So put the values right now. 1 by C1 that is 1 by 2 plus 1 by 3 plus 1 by 6. So here in this particular case, the LCM will be it will be 6. So if it is 6, so finally we will be getting, so it will be 3 plus 2 plus 1. So here how much will be getting? So it will be getting 6 by 6, that is 1. So here how much we are getting? So that means 1 by CS, what we are getting? It is 1. That means the value of CS will also be equal to 1. That means 1 microfarad, as all are of microfarad is. So that means the equivalent capacitance of this combination is 1 microfarad. That means this is a system like this. That means if we replace all the capacitor by a single capacitor, that means this is a capacitor of 1 microfarad which is connected across a cell of potential difference. How much? Potential difference is 10 volts. So that means what is the charge over this particular capacitor? So charge will be Q equal to C into V. So C equal to 1 microfarad, that means 10 to the minus 6 farad into potential difference is 10. So here how much we'll be getting? So 10 to the power minus 5. So or else we can write over that one as charge will be equal to 10 microcoulomb. तो चार्ज यहाँ पे कितना होगा? सिंपली 10 माइक्रोकूलम. दैट मीन्स ये जो 1 माइक्रोफैराड कैपेसिटर है इसमें चार्ज कितना आ रहा है? 10 माइक्रोकूलम. तो इसका मतलब ये है कि ये जो तीनों सीरीज में कनेक्टेड है, सीरीज में चार्जेस सेम रहता है कैपेसिटर्स के बीच में. तो चार्जेस यहाँ पे सभी में कितना रहेगा? जितना यहाँ पे हमें मिला 10 माइक्रोकूलम, हियर ऑल्सो 10 माइक्रोकूलम एंड हियर ऑल्सो विल गेट 10 माइक्रोकूलम. तो सभी में चार्जेस सेम रहेगा. तो यहाँ पे ऑप्शन कौन सा होगा? ऑप्शन बी विल बी द करेक्ट वन. Minimum number of capacitors, each of 8 microfarad and 250 volt, used to make a composite capacitor of 16 microfarad and 1000 volt are. So here what they are saying is that here how many minimum number of capacitors of 8 microfarad are required, मतलब कितना हमें कैपेसिटर यहाँ पे लेना है, फिर 8 हो या फिर 32 हो या फिर 16 हो या फिर 24, मतलब 8 माइक्रोफैराड वाला जो कैपेसिटर है हमें कितना नंबर में लेना है और उसको कैसे कनेक्ट करेंगे, क्लियर, सच दैट विल गेट 16 माइक्रोफैराड कैपेसिटर्स, क्लियर, 6, so that means what here in this particular case, और ये जो 8 माइक्रोफैराड है सब इसका पोटेंशियल कितना है, इसका पोटेंशियल है 250 वोल्ट इच, क्लियर। सो फाइनली हियर इन दिस पर्टिकुलर केस, तो एक चीज़ तो हमें यहाँ पे ध्यान में रखना है कि दो कैपेसिटर्स को जब हम सीरीज में कनेक्ट करेंगे तो मान लो कि कैपेसिटेंस है C1 एंड C2, तो इक्विवेलेंट कैपेसिटेंस कितना होगा, इक्विवेलेंट कैपेसिटेंस विल बी सिंपली हियर सीरीज में है तो C1 C2 डिवाइडेड बाय C1 प्लस C2, एंड ये जो इक्विवेलेंट कैपेसिटेंस जो भी यहाँ पे हमें मिल रहा है दैट विल बी लेस देन, ऑलवेज लेस देन द लीस्ट कैपेसिटर, मतलब लीस्ट वैल्यू ऑफ कैपेसिटेंस, तो जो लीस्ट वैल्यू ऑफ कैपेसिटेंस होगा इन दोनों में से C1 C2 में से उससे भी छोटा ये C इक्विवेलेंट। एंड सेकेंड थिंग, इसका जो पोटेंशियल डिफरेंस मान लो कि V1 एंड V2 है, तो नेट पोटेंशियल भी, नेट का वैल्यू कितना होगा, विल बी सिंपली V1 प्लस V2, पोटेंशियल डिफरेंस जनरली एडेड अप, क्लियर, इन सीरीज केस। तो इसका मतलब है कि अगर एक कैपेसिटर का जो वोल्टेज है 250 वोल्ट, ऐसा हमें कितना कैपेसिटर चाहिए ताकि टोटल वोल्टेज यहाँ पे हो जाएगा आपका 1000 वोल्ट, तो ऐसा हमें 4 चाहिए, जैसे जैसे कि यहाँ पे मान लो कि ये 2 हो गया तो 250 मीन्स 500 और 2 होगा तो 500, तो टोटल कितना हो जाएगा 1000 वोल्ट, तो मतलब यहाँ पे हम एज्यूम से 4 कैपेसिटर्स चाहिए, 4 कैपेसिटर्स ऑफ 8 माइक्रोफैराड ईच, तो 4 कैपेसिटर्स ऑफ 8 माइक्रोफैराड, दैट मीन्स यहाँ पे ये 250 वोल्ट का है, ये भी 250 वोल्ट का है, ये भी 250 वोल्ट एंड दिस वन इज ऑल्सो 250 वोल्ट, इसका कैपेसिटेंस 8 माइक्रोफैराड 8 माइक्रोफैराड 8 माइक्रोफैराड 8, तो दैट मीन्स इक्विवेलेंट कैपेसिटेंस सी इक्विवेलेंट यहाँ पे कितना होगा, तो सी इक्विवेलेंट विल बी, तो 1/c हमें करना है, 1/c इक्वल टू 1/8 प्लस 1/8 प्लस 1/8 प्लस 1/8, तो दैट मीन्स इट विल बी 4/8, और तो सी इक्विवेलेंट कितना होगा 8/4, तो 8/4 मतलब यहाँ पे ये कितना होगा 2 माइक्रोफैराड यहाँ पे होगा इक्विवेलेंट, क्लियर, एंड वी नेट यहाँ पे कितना आ रहा है हमें 1000 वोल्ट का मिल, मतलब ये जो सिस्टम है इसको अगर हम एक सिंगल कैपेसिटर से रिप्लेस करेंगे तो ये कितना होगा 2 माइक्रोफैराड और पोटेंशियल डिफरेंस कितना होगा 1000 वोल्ट। अच्छा, तो इसमें एक चीज़ तो हमें ये मिल गया कि सीरीज में अगर हम सभी को कनेक्ट करेंगे तो हमें कभी भी 16 माइक्रोफैराड नहीं मिलेगा, तो उसके लिए हमें क्या करना है, वी नीड टू अप्रोच टुवर्ड्स द पैरेलल कॉम्बिनेशन, तो हमें अभी क्या करना है कि पोटेंशियल डिफरेंस तो मिल गया 1000 हमें चाहिए, तो हमें ऐसे 1000 वोल्ट वाला पोटेंशियल डिफरेंस वाला जो कि 2 माइक्रोफैराड कैपेसिटर में होगा, ऐसे 2 माइक्रोफैराड वाला कैपेसिटर्स को अगर हम पैरेलल कनेक्ट करेंगे तो शायद हमें 16 माइक्रोफैराड मिल जाए, क्लियर, तो ऐसे 2 माइक्रोफैराड कैपेसिटर्स को अगर मान लो कि 2 को हम सिर्फ पैरेलल कनेक्ट करेंगे तो इक्विवेलेंट कितना होगा 4, तो 3 हो जाएगा तो कितना 6, और 4 हो जाएगा तो 8, तो 4 हो जाएगा तो 8 मतलब और 4 होगा तो कितना 16 हो जाएगा, तो ऐसे हमें कितना चाहिए, ऐसे हमें 8 चाहिए, क्लियर, 8 मीन्स 2 माइक्रोफैराड कैपेसिटर्स और वो भी कितना 8, तो 2 माइक्रो दैट मीन्स वी नीड 8 वी नीड, तो वी नीड 8 2 माइक्रोफैराड कैपेसिटर्स to make a single 16 माइक्रोफैराड कैपेसिटर, तो इस वाले पर्टिकुलर केस में तो यहाँ पे ये वाला केस में हमें मिल सकता है, क्लियर, तो 8 चाहिए, तो बट हमें यहाँ पे क्वेश्चन में पूछा गया कि 8 माइक्रोफैराड वाला कितना लेना है, क्लियर, तो हर एक 2 माइक्रोफैराड बन रहा है कितना 8 माइक्रोफैराड कैपेसिटर को लेके 4 को लेके बन रहा है, तो इसमें 4 8 माइक्रोफैराड कैपेसिटर यहाँ पे प्रेजेंट है, तो इसमें भी 4 है, इसमें भी 4 है, क्लियर, और इसमें भी 4, ऐसे हमें कितना चाहिए, ऐसे सीरीज में 4 कनेक्टेड है और ऐसे 4 वाला 8 माइक्रोफैराड पैरेलली कितना है, पैरेलली 8 है, तो टोटल कितना होगा, सो 4 इंटू 8 दैट मीन्स 32 नंबर, तो यहाँ पे हमें कितना चाहिए 32 नंबर्स यहाँ पे चाहिए। फॉर एग्जाम्पल अगर हम फिगर को थोड़ा देखें यहाँ पे ये जो कॉम्बिनेशन होगा दिस कॉम्बिनेशन वुड बी समथिंग लाइक, क्लियर, ये जो कॉम्बिनेशन है ये ऐसा है, ये हर एक यहाँ पे 8 8 8 8, यहाँ पे ये सभी यहाँ पे कितना है 8 माइक्रोफैराड वाला कैपेसिटर है, क्लियर। और ये सभी का पोटेंशियल डिफरेंस कितना 250 250, तो यहाँ पे सीरीज में हमें 1000 वोल्ट मिल रहा है पोटेंशियल डिफरेंस, नेक्स्ट सीरीज में भी हमें पोटेंशियल डिफरेंस 1000 वोल्ट मिल रहा है, नेक्स्ट सीरीज में भी हमें पोटेंशियल डिफरेंस 1000, तो हर एक सीरीज में हमें पोटेंशियल डिफरेंस कितना मिला है 1000 यहाँ पे सब मिला है। तो ये जो 1000 वोल्ट वाला 1000 वोल्ट जो कि पैरेलल में मिल रहा है, तो नेट पोटेंशियल डिफरेंस इसके अक्रॉस ये जो कॉम्बिनेशन है नेट पोटेंशियल डिफरेंस हमें कितना मिलेगा 1000 वोल्ट ही मिलेगा, क्लियर। तो ये वाला चीज़ है, तो हमें टोटल नंबर कितना चाहिए यहाँ पे 32 कैपेसिटर्स चाहिए ऑफ 8 माइक्रोफैराड, तो ऑप्शन बी विल बी द करेक्ट वन। A capacitor of capacitance C1 is charged to a potential V and then connected in parallel to an uncharged capacitor. It is connected in parallel to an uncharged capacitor of capacitance C2. The final potential difference across each capacitor. So what it is saying is that there are two capacitors. One is C1 and another capacitor, let it be C2. Clear? So here in this particular case, this is C2. So these two are connected in parallel, but before connection one is already charged to a potential difference V, clear. So that means this C1 is having potential difference B, but C2 is uncharged, clear. So it is having potential difference that is 0. So when these two are connected in parallel, clear, then what will happen? So this capacitor C1 that will start discharging, clear, यहाँ पे discharge होगा and finally C2 will get charged. तो C2 यहाँ पे क्या होगा C2 चार्ज होगा, क्लियर। तो C2 चार्ज कितना तक होगा, क्लियर। तो यहाँ पे ये बोला था कॉन्सेप्ट ये है C2 will get charged till both the capacitors possess common potential, till both the capacitor possess common potential। तो कॉमन पोटेंशियल का जो वैल्यू होगा, मान लो कि दोनों चार्ज मतलब यहाँ पे डिस्चार्जिंग प्रोसेस शुरू हुआ, देन आफ्टर दैट व्हाट विल हैपन, एक कॉमन पोटेंशियल अचीव होने के बाद फाइनल क्या होगा, ये डिस्चार्जिंग प्रोसेस यहाँ पे स्टॉप हो जाएगा। दैट मीन्स कैपेसिटर C1 में जो चार्ज होगा कुछ ट्रांसफर होकर यहाँ पे C2 में आएगा, क्लियर। सो फाइनली हियर व्हाट विल बी द वैल्यू ऑफ दैट कॉमन पोटेंशियल। सो कॉमन पोटेंशियल जो होगा, मान लो कि हम उसको V पाइप से इंडिकेट करते हैं, तो कॉमन पोटेंशियल का जो फॉर्मूला होता है वो कितना होता है, सिंपली Q1 प्लस Q2 डिवाइडेड बाय C1 प्लस C2 इक्वल टू Q बाई C। तो टोटल चार्ज विच इज प्रेजेंट इन द फर्स्ट कैपेसिटर और C1 कैपेसिटर, सो दैट विल बी हाउ मच, so that will be C1 into V, clear, and total charge that will be present on capacitor C2 before discharging, that will be how much, that will be 0, all divided by capacitance C1, that is C1 plus C2. That means, so finally how much will you getting, so it will be C1 into V divided by C1 plus C2. So here in this particular case, the common potential, this is the formula to find out the common potential. So this is what, this is the common potential. So here you can see, so C1V divided by C1 plus P2. So option A is saying the same, C1V plus C1 plus C2. The rest other C2 it is wrong and also wrong, no terms of potential. Here C and D में तो potential का term ही नहीं है. This is saying about the capacitance only, clear. So option A will be the correct one. Two capacitors of 2 microfarad and 4 microfarad are connected in parallel. So there is, what they are first saying is that there are two capacitors, one is 2 microfarad and another one is of 4 microfarad. This is 4 microfarad which are connected in parallel, clear. And a third capacitor 6 microfarad is connected in series. There is another capacitor which is of 6 microfarad. This is 6 microfarad which is connected in series, and that combination is connected across a 12 volt battery. That means this combination is right now which is connected across a 12 volt supply, 12 volt battery. The voltage across 2 microfarad capacitor is, so here in this particular case 2 microfarad and 4 microfarad capacitor, as these two are connected in parallel, that means that what will be their equivalent capacitance? Their equivalent capacitance will be 6 माइक्रोफैराड. तो इसका मतलब है कि ये जो सिस्टम है यहाँ पे इसका जो इक्विवेलेंट कैपेसिटेंस हमें यहाँ पे कितना मिलेगा? तो ये 2 + 4 दैट विल बी ऑफ 6 माइक्रोफैराड. क्लियर? तो ये जो 6 माइक्रोफैराड को अगर हम यहाँ पे कनेक्ट करेंगे, यहाँ पे ये वाला केस. क्लियर? तो राइट नाउ व्हाट वी आर डूइंग, वी आर कनेक्टिंग ए 6 माइक्रोफैराड कैपेसिटर which is the equivalent of this 2 and 4. तो इसका मतलब 6 and 6 बोथ आर सेम कैपेसिटर्स. दैट मीन्स पोटेंशियल डिफरेंस यहाँ पे कितना होगा? यहाँ पे भी 6 वोल्ट का होगा और यहाँ पे भी कितना होगा? 6 वोल्ट का मिलेगा हमें. क्लियर? ऑब्वियसली द वोल्टेज सप्लाई विल बी डिवाइडेड बिटवीन द टू कैपेसिटर्स. क्लियर? तो इसमें ये जो 6 माइक्रोफैराड कैपेसिटर, ये वाला पार्ट ग्रीन कलर का है, इसके क्रॉस पोटेंशियल डिफरेंस कितना आ रहा है? 6 वोल्ट. क्लियर? तो उसका मतलब है कि ये जो सिस्टम है, इस सिस्टम के ऊपर हम के अक्रॉस हमारा पोटेंशियल डिफरेंस कितना होगा? दैट विल बी 6 वोल्ट. तो एज दिस 2 and 4 आर कनेक्टेड इन पैरेलल, ये दोनों पैरेलल में कनेक्ट है, तो 4 के अक्रॉस भी पोटेंशियल डिफरेंस कितना होगा? 6 होगा. और 2 माइक्रोफैराड के अक्रॉस कैपेसिटर के अक्रॉस भी पोटेंशियल डिफरेंस कितना होगा? 6 वोल्ट होगा. सो फाइनली हियर इन दिस पर्टिकुलर केस द वोल्टेज अक्रॉस 2 माइक्रोफैराड कैपेसिटर इज 286. so it will be 6 volt. Two identical capacitors are joined in parallel, charged to a potential V, separated and then connected in series. The positive plate of one is connected to the negative plate of other. So here what it is saying is that, so there are two parallel plate capacitors. Assume this one is a capacitor and we'll take another capacitor of same capacitance. Clear? So it is having capacitance C, it is also having capacitance C, and both are connected in parallel across a voltage source. Let the voltage source is having potential difference V. So that means the potential difference across both the capacitors will be V and V. Clear? So here in this particular case, right now what they are saying is that they are separate. Right now after connecting them parallel and having the potentials V each across both capacitor, they are separated and then connected in series. So these two capacitors will be separated from each other and they will be connected in series. So that means capacitance will remain as it is and potential difference across both will be V each. Clear? So if it is the case, then what it is and second thing what they are saying is that suppose they are charged, that means this will be positive and this will be negative. Here this one is positive and here it is negative. That means positive terminal, or you can say positive plate of one capacitor is connected to the negative. So here if this is positive, so this is negative, so this is positive and negative. That means positive negatives are connected here. That means this is called series combination. Then which of the following is true? So that means potential difference here is V and potential difference here is V. The charge on the free plates connected together are destroyed. So here in this particular case, so this particular capacitor, first one that will be having a charge Q will be equal to CV. Clear? Second capacitor will be having the same charge, that will be same CV, because both are having same capacitance and same potential difference is there. So charge is destroyed, that is wrong. Charge will not be destroyed over here. The energy stored in the system increases. So here in this particular case, energy stored in the system. So energy stored in the system is nothing but half CV square. Clear? So here in this particular case, if we just look at the equivalent capacitance of this combination, that will be 2C. Clear? And potential difference across both is V. So that means what will be the energy stored? Energy stored will be half CV square, half 2C into V square. So 2 will get cancelled out, then potential energy stored, or you can say energy stored will be how much? It will be CV square. But in series combination, when we connect these two capacitors in series, then their equivalent capacitance will be C by 2 as they are connected in series. And here in this particular case, then energy stored will be how much? It will be half CV square. That means here in this particular case, we can say that the net potential difference will be how much? 2V. So it will be 2V square. So finally half CV square means capacitance is C by 2 and potential difference is how much? It will be 2V. So we'll be taking the net potential difference. So it will be C by 4, it will be C by 4 into 4V square. So 4 get cancelled, so how much we are getting? We are getting the same. Clear? So here what is saying, energy stored in the system increases, so it remains, it does not change. Clear? Energy stored remains as it is. Next, the potential difference between the free plates is 2V. पोटेंशियल डिफरेंस बिटवीन द फ्री प्लेट्स, तो ये जो प्लेट्स सीरीज कनेक्शन होने के बाद, क्लियर, क्वेश्चन में ये आ रहा है कि सीरीज कनेक्शन होने के बाद जो पोटेंशियल डिफरेंस रहेगा बिटवीन द प्लेट्स, तो वो कितना होगा? तो पोटेंशियल डिफरेंस हाउ मच विल बी कमिंग? सो नेट पोटेंशियल V net will be here simply V1 plus V2, potential difference across the first and second, so it is nothing but V plus V, that will be 2V. So net potential difference यहाँ पे कितना आएगा? That will be 2V. So this is correct. And potential difference remains constant. Potential difference जो है वो यहाँ पे constant रहेगा. यहाँ पे ये बोला जा रहा है कि potential difference will remain constant. So here in this particular case when they were connected in parallel, तो potential difference, net potential difference कितना था? V. अब जब हम सीरीज में कनेक्ट करें तो नेट पोटेंशियल डिफरेंस हमें कितना मिला? 2B. तो ये कांस्टेंट नहीं है, पोटेंशियल डिफरेंस इज इंक्रीजिंग ओवर हियर, सो दैट इज आल्सो wrong. So option C will be the correct one. In the given circuit, initially K1 is closed and K2 is opened. K1 is closed, that means it is closed, and K2 is opened. K2 is opened over here. Okay, fine. Then after that, so here in this particular case, what will happen? Once K1 is closed and K2 is open, that means there will be no flow of current in the circuit. That means C1 here it will get charged, but C2 will not be charged. Clear? So when K2 is opened and K1 is closed, then C1 will get charged. So it will get charged and it will be having a potential of V, same as the potential applied over here. Next, then K1 is opened and K2 is closed. So initially C1 is charged, but C2 is not charged, so its potential net charge is 0, and this C1 capacitor is having a charge. It is having the initial charge of C1V, and that means this is the charge on C1, and the charge on C2 will be 0. That is when K1 is closed and K2 is opened. K2 जब open रहेगा. Next, then K1 is opened and K2 is closed. So here after that, what is the thing? So K1 is opened, K1 will be opened over here, and K2 will be closed. After that, K2 will be closed over here. So here that means right after this one, as C1 capacitor C1 is already charged, having a potential of V, and C2 which is not charged, uncharged, so that means there will be charging. That means here C2 will get charged and discharging of C1 will take place. Clear? So initially here in this particular case, what actually will happen, discharging of capacitor C1 will take place and charging of capacitor C2 will take place, and it will take place this kind of charging and discharging process will, that means this is a redistribution of charges. Clear? So what will happen over here when K1 is opened and K2 is closed, and after that what will happen? This means redistribution of charges will take place. तो रीडिस्ट्रीब्यूशन ऑफ चार्जेस यहाँ पे जो होगा, तो उसमें कितना तक रीडिस्ट्रीब्यूशन होगा? जब तक ये दोनों का पोटेंशियल सेम ना हो. क्लियर? सो दैट मीन्स हियर इन दिस पर्टिकुलर केस टिल बोथ विल अचीव कॉमन पोटेंशियल, लेट इट बी V प्राइम. क्लियर? तो फाइनली यहाँ पे ये बोला जा रहा है, सो बट इफ Q1 प्राइम एंड Q2 प्राइम आर द चार्जेस ऑन C1 एंड C2, बट यहाँ पे ये बोला जा रहा है कि फाइनल जो ऐसा, ये जो दो एक्सपेरिमेंट करने के बाद यहाँ पे ये बोला जा रहा है कि जो सिस्टम है, इस सिस्टम में जो चार्ज C1 जो कैपेसिटर है, इसमें चार्ज कितना आ रहा है? चार्ज आ रहा है Q1 प्राइम, और C2 जो कैपेसिटर है उसमें चार्ज कितना आ रहा है? Q2 प्राइम. क्लियर? दैट इज आफ्टर द होल एक्सपेरिमेंट. क्लियर? एंड पोटेंशियल्स दैट आर कमिंग ओवर हियर, पोटेंशियल यहाँ पे आ रहा है V1 एंड यहाँ पे पोटेंशियल आ रहा है V2, क्लियर। तो यहाँ पे ऐसा है, दैट मीन्स हियर इन दिस पर्टिकुलर केस तो कॉमन पोटेंशियल जो होगा आफ्टर रीडिस्ट्रीब्यूशन V प्राइम, दैट V प्राइम विल बी इक्वल टू V1 एंड दैट विल बी इक्वल टू V2, तो ये सेम रहेगा, क्लियर। तो ये वाला केस यहाँ पे होता है, क्लियर। तो इसमें ऑप्शन अभी हम चेक करेंगे कि कौन सा ऑप्शन यहाँ पे सही है। सो फर्स्ट ऑप्शन व्हाट इट इज सेइंग, चार्ज ऑन C1, जो चार्ज यहाँ पे पहले से था C1V, दैट चार्ज विल गेट रीडिस्ट्रीब्यूटेड सच दैट V1 इक्वल टू V2, तो ये रीडिस्ट्रीब्यूशन उसका होगा, मतलब जो C2 पहले से अनचार्ज था वो चार्ज होगा, तो कितना तक चार्ज हो सकता है, जब तक दोनों का पोटेंशियल सेम ना हो, क्लियर। तो फाइनली यहाँ पे दोनों का पोटेंशियल सेम होगा, सो दैट मीन्स दिस ऑप्शन इज करेक्ट। देन चार्ज ऑन C1 गेट डिस्ट्रीब्यूटेड सच दैट Q1 प्राइम इक्वल टू Q2 प्राइम, तो चार्ज का यहाँ पे ये बोला जा रहा है कि चार्ज का जो रीडिस्ट्रीब्यूशन होगा वो कब तक होगा, जब तक ये दोनों कैपेसिटर प्लेट में चार्ज सेम हो जाए, क्लियर। तो ऐसा कोई कंडीशन यहाँ पे नहीं है, मतलब यहाँ पे जैसा हमारा कॉन्सेप्ट यही बोलता है कि रीडिस्ट्रीब्यूशन ऑफ चार्जेस कब तक होगा, जब तक पोटेंशियल सेम हो, क्लियर। तो यहाँ पे ऐसा कोई कॉन्सेप्ट नहीं है कि चार्ज जब तक सेम अमाउंट में चार्ज रीडिस्ट्रीब्यूशन हो जाए तब तक वहाँ पे रीडिस्ट्रीब्यूशन चलता रहेगा, तो ये यहाँ पे रॉन्ग होगा, क्लियर। देन चार्ज ऑन C1 गेट रीडिस्ट्रीब्यूटेड सच दैट C1V1 इक्वल टू C2V2 इक्वल टू C1V, तो यहाँ पे C1V1, सो यहाँ पे बोला जा रहा है कि रीडिस्ट्रीब्यूशन कब तक होगा, जब तक कि Q जो कि C1V है, दिस इज Q एंड C2V2 इज नथिंग बट Q2 एंड C1V1 इज नथिंग बट Q1, दैट मीन्स यहाँ पे बोला जा रहा है कि Q1 इक्वल टू Q2 इक्वल टू Q। तो इसमें पहले जब K2 ओपन था तो जो चार्ज था यहाँ पे Q था, तो रीडिस्ट्रीब्यूशन होने के बाद तो चार्ज उतना ही नहीं रहेगा, क्लियर। तो इसलिए ये वाला भी यहाँ पे रॉन्ग है, रीडिस्ट्रीब्यूशन हो रहा है मतलब इससे कुछ चार्ज निकल के इधर आ रहा है, ये वाला कैपेसिटर चार्ज हो रहा है, तो जो नेट चार्ज C1 पे होगा दैट नेट चार्ज Q1 प्राइम विल बी लेस देन Q, तो ये हमेशा लेस देन ही होगा, क्लियर। तो फाइनल नेक्स्ट, चार्ज ऑन C1 गेट रीडिस्ट्रीब्यूटेड such that Q1 प्राइम प्लस Q2 प्राइम, Q1 प्राइम प्लस Q2 प्राइम विल बी इक्वल टू 2Q। तो इस वाले फैक्टर में यहाँ पे भी वैसा ही केस है कि रीडिस्ट्रीब्यूशन होगा, ताकि जो नेट चार्ज यहाँ पे आ रहा है, जो बोला जा रहा है कि आफ्टर द होल प्रोसेस कैपेसिटर C1 में चार्ज आएगा Q1 प्राइम एंड कैपेसिटर C2 में जो चार्ज आएगा वो Q2 प्राइम है, दोनों का सम का वैल्यू कितना वो बोला जा रहा है, दोनों का सम होगा 2Q, बट दैट इज बी रॉन्ग, व्हाई, बिकॉज रीडिस्ट्रीब्यूशन होने के बाद जो सिस्टम में चार्जेस आ रहा है वो है Q1 प्राइम एंड Q2 प्राइम, और ये जो टोटल चार्ज इन दोनों का सम किसके साथ बराबर होना चाहिए, वो Q के साथ, क्योंकि बिफोर रीडिस्ट्रीब्यूशन ऑफ चार्जेस नेट चार्ज ऑन द कैपेसिटर C1 इज Q, ये मान लो कि Q है, क्लियर। तो ये Q चार्ज जो है वो रीडिस्ट्रीब्यूट हो रहा है, मतलब C1 से कुछ चार्ज यहाँ पे C2 तक आ रहा है, कब तक रीडिस्ट्रीब्यूशन होगा, जब तक पोटेंशियल सेम ना हो, तो मतलब यहाँ पे रीडिस्ट्रीब्यूशन होने के बाद C1 में जो चार्ज आ रहा है Q1 प्राइम और C2 में जो चार्ज आएगा Q2 प्राइम, तो इन दोनों का सम कितना होना चाहिए, Q होना चाहिए, इट शुड नॉट बी 2Q, दैट मीन्स इट इज ऑल्सो रॉन्ग। तो हियर इन दिस पर्टिकुलर केस ऑप्शन A इज द करेक्ट वन। A parallel plate capacitor is made by placing n equally spaced plates. That means how many plates they have taken? They have taken n equally spaced plates and connected alternatively. So that means these plates are connected alternatively. If the capacitance between any two adjacent plates is C, then the resultant capacitance. So here in this particular case, suppose we'll take few plates over here, and these few plates are arranged somehow as the question is said. So here in this particular case, if we just see there are some plates which are present over here. This is plate number 1, 2, 3, 4, 5, 6, 7 and 8. So number of plates is number of plates is 8. Clear? And if we just look at the color of the plates, that means these black color plates are connected to the positive terminal of the battery. Clear? And these red color plates are connected to the negative terminal of the battery. Okay, So here in this particular case, as these black color plates are connected to the positive terminal of the battery, that means they will acquire positive charge. Black color plates will acquire positive charge over here, and the red color plates over here, they will acquire negative charge. Red colors will acquire negative charges. So here in this particular case, if as the spacing is same over here between all the plates, so we can say that this black and red, this one pair will form a capacitor, and this second, that means this first and second, suppose let me name these plates over here. This is first plate, this is second plate, this is third, fourth, fifth, sixth, seventh, and 8th. That means this 1 and 2, this 1 and 2 will form a capacitor. Clear? And similarly this 2 and 3 will also form a capacitor. Similarly 3 and 4, 4 and 5, 5 and 6, 6, 7, and 7, 8 last. So 7, 8, 6, 7, 5, 6, 4, 5. So all these form a, that means they will form a capacitor. That means how many capacitors are formed by taking 8 plates? 1, 2, 3, 4, 5, 6, 7. So that means here number of capacitors is how much? It is 7. So that means here we just come to know that if 8 plates are there and they are connected alternatively, that means one after another, that means odd numbers are connected to each other with with positive potential, and even number of plates are connected to the negative potential, and that means here adjacent plates will behave as capacitors. So here in this particular case, what we can say, if number of plates is n, that implies number of capacitors will be how much? It will be n minus 1. So n minus 1 per capacitor वहाँ पे formation होगा. Clear? Right. Now another thing, here in this particular case, suppose if this kind of arrangement is given, and what they are asking the resultant capacitance. What will be the resultant capacitance? So here in this particular case, so if we just look closely, this one, suppose if this is having positive potential, let it be indicated by VA, and this is having negative potential, let it be indicated by VB. So here in this particular case, this black colored plates are connected to positive terminal, and red colored plates are connected to the negative terminal. So that means here in this particular case, if I take 2 points over here, let it be A and B. Clear? So that means A is having some positive potential and B is having some negative potential. So here in this particular case, if I will try to do some arrangement over here, try to make the capacitors arrange over here, how these capacitors are arranged. Clear? So here in this particular case, first capacitor between 1 and 2, 1 is connected to the positive and 2 is connected to the negative. So A is positive over here, A is positive over here, and B is negative over here. Clear? So one is connected to positive and 2 is connected to negative. That means 1 and 2 is a capacitor which is connected between A and B. Similarly 2 and 3 are also connected between A and B. 3 and 4 is also connected between A and B. Then 4 and 5, these are also connected between A and B. Then 5, 6 is also connected between A and B. Then 6, 7 is also connected between A and B. And final 7 and 8 is also connected between A and B. Clear? So here in this particular case, we can say that here, that means if this is connected to A here, if this is connected to A, this is also connected to A and A. And similarly here, it will, if it is connected to B, means it is B, and here it will be B. Clear? So that means how many capacitors are formed right now? So 1, 2, 3, 4, 5, 6, 7 capacitors which are arranged parallelly. तो 7 कैपेसिटर्स यहाँ पे पैरेलली अरेंज है और यहाँ पे ईच कैपेसिटर का कैपेसिटेंस मान लो कि C है. क्लियर. ईच कैपेसिटर का कैपेसिटेंस अगर C है, देन व्हाट विल द इक्विवेलेंट कैपेसिटेंस? इक्विवेलेंट कैपेसिटेंस C इक्विवेलेंट विल बी हाउ मच? इट विल बी 7C. क्लियर. But that means what? That indicates if 8 plates are given, then it will be 8 minus 1 into C. Clear? So similarly, here in this particular case, as n plates are given, n number of plates are given, that means number of capacitors formed are n minus 1. That means the equivalent capacitance, that means here in this particular case, C equivalent will be equal to how much? It will be n minus 1 into C. So finally, in this particular case, n minus 1 into C, so option D will be the correct one. Two parallel conducting plates, each of area A equal to 2.5 meter square, each are placed 6 mm apart. That means two parallel conducting plates. So which one they are saying? They are saying about 1 and 3. Clear? That's 1 and 3, which these two plates are having area 2.5 meter square and are placed 6 mm. The distance between 1 and 3 6 mm and are both arched. That means plate 1 and 3 are arched. Okay. A third plate identical with the first two, that means having the same area, clear, is placed at a distance of 2 mm from one of the arched plates. That means at a distance of 2 mm means as shown in the figure, this second plate is placed at a distance of 2 mm from the first and at a distance of 4 mm from the third. And here, and it's given a charge of 1 coulomb. That means this second over plate, here it is given some charge, clear, charge of 1 coulomb. That means it is given positive charges, so it will possess positive charges on the plates, and these charges will be distributed on both sides of the plate. So that means due to induction, what will happen? A negative charges will appear on the inner face of the first and third plate. Negative charges यहाँ पे फर्स्ट एंड थर्ड प्लेट में इनर सरफेस में दिखाई देगा, और पॉजिटिव चार्जेस जो होगा वो आउटसाइड होना चाहिए. पॉजिटिव चार्जेस जो होगा वो यहाँ पे आउटसाइड में यहाँ पे रहना चाहिए. दीज आर पॉजिटिव चार्जेस विल ऑन द आउटसाइड, but these positive charges will not remain. Why? Because as the outer part of both the plates are arched, that means electrons will flow from the ground to the plate and they will neutralize the positive charges. So that means there will be no charges on the outer part of the first and third plate. And also second thing is that as these two plates are arched, it means their potential will be zero. Potential of those two plates will be zero. That means zero potential. So here in this particular case, if we try to arrange these two, then, and second, finally, what is asking? The potential of the central plate. That means here this plate might be connected to this plate, might be connected to some potential. Clear? So let the potential over here, it's something, let it be it is connected to some terminal, so let that terminal be A, and these two terminals which are arched, let us indicate those terminal be B. Clear? So here in this particular case, if we take over here that terminal A and terminal B, so between terminal A and terminal B, so what will happen? So this 1 and 2 will form capacitor system, 2 and 3 will form capacitors. Here, so that means there are two capacitors. So here we have taken 3 plates, and we know that if 3 plates are there, they will form 2 capacitors. So if 2 capacitors between 1 and 2, between 1 2 and between 2 3, 2 3 means 3 2, we can say as 3 and 1, 3 and 1 here are connected to 3 and 1 are connected to the 3 and 1 are connected to, we can say this is 3 and 1 are connected to terminal B. 3 and 1 are connected to terminal B, and 2 second plate is connected to A. Second plate here we have indicated by 2 plates. Actually it is not 2 plate, it is a single plate. Clear? It should be a single plate over here, and that single plate will be connected to A. So as this single plate इट्स इक्वली शेयर्ड बाय बोथ 1 and 3. दैट मीन्स ये इक्वली यहाँ पे 1 के साथ भी इसका शेयरिंग हो रहा है और सिमिलरली 3 के साथ भी इसका शेयरिंग हो रहा है. दैट मीन्स दिस सिंगल प्लेट विच इज प्लेट नंबर 2 that will form a capacitor system with one capacitor system with 1 as well as capacitor system with 3. Clear? तो ये वाला केस, that's why there are two capacitors. Clear? Okay, right now here in this particular case, इसको अगर हम ऐसे थोड़ा समझ लें, अभी मान लें कि ये सेपरेटेड है. क्लियर? ये थोड़ा सेपरेटेड, दैट मीन्स व्हाट, तो 1 and 2 के बीच में ये वही हमारा 2 रहा. दिस इज द सेम 2 सेकेंड प्लेट. तो ये 1 and 2 एक कैपेसिटर बनना है, 2 3 एक कैपेसिटर बनना है. क्लियर? so these two capacitors are connected in parallel. So how they are connected in parallel? So assume that these are two capacitors which are connected in parallel. Clear? So connected in parallel across the positive and negative terminals, or you can say across A and across B. Okay, fine. So then what is the capacitance of द कैपेसिटर 1 and 2. सो प्लेट 1 and 2 का जो कैपेसिटर फॉर्मेशन हो रहा है तो उसका कैपेसिटेंस कितना होगा? सो कैपेसिटेंस विल बी नथिंग बट, अगर हम ये 2 mm को यहाँ पे डिस्टेंस d एज्यूम करेंगे, इफ विल कंसिडर दिस 2 mm, इफ d इक्वल टू 2 mm. क्लियर? देन हियर इन दिस पर्टिकुलर केस कैपेसिटेंस ऑफ between 1 and 2 will be how much? Equal to epsilon naught A divided by D. Clear? And similarly capacitance between 2 and 3, capacitance between 2 and 3 will be how much? It will be epsilon naught. Area, as area is same, so no, there is no change, but here the distance become how much? That becomes 2d, because as it is 4, it's d equal to d is taken 2, so that means that 4 mm can be written as 2d. Clear? So finally over here what you can say that means if this C12 is indicated by C, then this will be C23 will be how much? It will be C by 2. That means if this is C and this is C by 2. So here in this particular case, the equivalent capacitance will be equal to C plus C by 2, and that will be equal to 3C by 2 or 3 by 2C. That means this equivalent capacitance is how much it is coming? It is coming to 3 by 2C. That means here in this particular case, if we draw a figure indicating that this is A and this is B. Clear? So here B terminal is having zero potential, B terminal is having zero potential, and this A terminal is having some potential. Let the potential at A be and potential at B be 0. Clear? Then what will be the potential difference we'll be getting across this 3 by 2C capacitor? So that potential will be V will be equal to how much? V will be equal to Q by C. Clear? And that is C equivalent. Clear? Q by C. So here in this particular case, that means here how much charge they have given over here. That charge they have given over here is 1 coulomb. Clear? And what is the equivalent capacitance? Just we have calculated right now. Equivalent capacitance is 3C by 2. Clear? So it is coming out to 3C by 2. That means we can write over here it is, or let it be Q. Okay, just we are getting a formula. After that we'll put the values. So it will be how much? 2Q divided by 3C. Okay, fine. So but the value of C, how much we have taken, it is considered to be epsilon naught A by D. That means the potential, or you can say potential difference across the plates of the equivalent capacitance is how much? It will be 2Q divided by 3C, means epsilon naught A divided by D. Clear? So D, that will goes to the numerator, so it will be 2QD divided by 3 epsilon. So remember D we have taken 2 mm. Clear? So finally if we put all these values right over here, so either of the plate, यहाँ पे और एक चीज हमें ध्यान में रखना है कि इस वाले पर्टिकुलर केस में जो चार्जेस यहाँ पे प्रेजेंट है वो चार्ज कितना है? यहाँ पे चार्ज है यहाँ पे Q माइनस Q एंड माइनस Q. क्लियर? तो सो यहाँ पे भी प्लस, यहाँ पे ये हमारा सेकेंड प्लेट जो पॉजिटिव चार्ज है तो प्लस Q चार्ज यहाँ पे रहेगा हमारा. क्लियर? तो इसमें कितना चार्ज होगा? माइनस Q, और यहाँ पे भी माइनस Q का चार्ज रहेगा. क्लियर? सो फाइनली हियर इन दिस पर्टिकुलर केस चार्ज हमें कितना प्रोवाइड किया गया है, चार्ज हमें दिया गया है 1 कूलम का. So here in this particular case we put the values 2 into 1 and distance is how much, d is taken 2 mm. clear, distance यहाँ पे हम लोग consider करेंगे कितना 2 mm. so 2 into 10 to the power minus 3 meter divided by 3 into epsilon naught is 8.85 into 10 to the power minus 12 into area. Area is given and that value is 2.5 meter square. Area given is 2.5 meter square, so no need to convert that one. So right now how we'll get this particular value is that, so here it will be 2 into 2, that is 4 into 10 to the power minus 3, 4 divided by, it will be 3 into 8.85 into 2.5, it will be uh, 7.5 into 8.85 and 10 to the power minus 12. If it goes up, so then it will be 10 to the power plus 12. So it will be this one. So it will be how much? So it is coming out to be 4 upon 7.5 into 8.85. It will be 10 to the power 9. So here in this particular case, if I take suppose 2 zeros over here, so that value will be something 400 into 10 to the power 7 whole divided by 7.5 into 8.85. So here approximately, if I'll take suppose 7.5 and 8.85, it is approximately 8.9, or you can take 9. Clear? So 8.9. So doing the calculations over here, and that can be written over here like so let it be 4 into 100 into 10 to the power 7 over here divided by let it be 77.5 into 8.9, assume 8.9 approximately we have taken. So finally it will be 0.3 and it will be 4. So 25 से इसको काट रहे हैं, finally write that one is 3 by 40. Clear? So it will be 3 by 40. So approximately how much we will get? So 3, that means here it will let me approximately cut that one by 13. Clear? Approximately 13, that means it actually more than 13, so it will be 13 for the 52, so we'll get approximately 53. Assume that it is 53 and 53 and here 8.9, approximately if we'll take it to 9, so then into 10 to the power 7. So here doing approximations, so we might get the result nearly approximately equal to 6 into 10 to the power 7. 6 into the 10 to the power 7, something more than 6 we'll get over here. So we'll check whether we are getting a nearly equal to 6. That is 6 into 10 to the power 7, then 3, 4, 2. So as no other options possess the value nearly equal to 6, or if something, if 2, 3 value was given like 6.25 into 10 to the 7 or 6.1 into 10 to the 7 or 0.59 into 10 to the 7, then we have to do the actual calculation. So here by doing by taking some approximate values, what we are getting, it is 6 into 10 to the 7 approximately. So that means here option A will be the correct one. 3 capacitors, each of capacity 4 microfarad, are to be connected in such a way that the effective capacitance is 6 microfarad. So here what it is saying is that there are 3 capacitors. 3 capacitors, this is given, one capacitor, another capacitor they have given over here, and another capacitor, that is the third capacitor, and each capacitor is of 4 microfarad. This is also 4 microfarad and this one is also 4 microfarad. So having same capacitance, and what they are saying is that just connect them in such a way that we'll get an equivalent or effective capacitance of how much, 6 microfarad. So as we know that 6, we want 6 over here, so 3 4s are there, that means 4 plus 2 can be 6. Clear? So that means keep one capacitor as it is. and here we need, that means here in this particular case, ये जो दो कोई भी दो कैपेसिटर को लेके हमें उसको 2 बनाना है, और एक कैपेसिटर जो 4 है उसको हमें एज इट रखना है, एज इट इज हमें उसको रखना है। दैट मीन्स हियर इन दिस पर्टिकुलर केस, तो 4 माइक्रोफैराड कैपेसिटर को जो दोनों है, here if we connect them in series, then they will give us their equivalent capacitance will be what? Their equivalent capacitance will be 2 microfarad. That means if these two capacitors are connected in series over here, इन दोनों का भी हम यहाँ पे सीरीज में कनेक्ट कर रहे हैं, दैट मीन्स देयर इक्विवेलेंट कैपेसिटेंस विल बी हाउ मच? 2 माइक्रोफैराड। क्लियर? दोनों का इक्विवेलेंट कैपेसिटेंस यहाँ पे कितना होगा? 2 माइक्रोफैराड। कैसे? सो इट विल बी 1/c इक्वल टू 1/4 प्लस 1/4, so it means it is 2/4, that means c will be equal to 2। तो इक्विवेलेंट कैपेसिटेंस हमें कितना मिला है? 2 माइक्रोफैराड। एंड what we'll do, will if we're getting, that means the third one must be connected in parallel with them. That means here how will you connect the third one over here? Third one must be connected in parallel with rest other two। इन दोनों के साथ पैरेलल यहाँ पे कनेक्ट होना चाहिए। क्लियर? तो इसमें हमें ऑप्शन अभी चूज करना है, कनेक्टिंग देम इन सीरीज। तो सभी को हम अगर सीरीज में कनेक्ट करेंगे तो इक्विवेलेंट कैपेसिटेंस कितना होगा? 4/3। कनेक्टिंग पैरेलल इन देम, अगर सभी को हम तीनों को पैरेलल कनेक्ट करेंगे तो इक्विवेलेंट कैपेसिटेंस कितना होगा? 12 माइक्रोफैराड। क्लियर? ये 4/3, दैट मीन्स 1.33 माइक्रोफैराड होगा पहला केस में, 1.33 माइक्रोफैराड, एंड दिस इज 12 माइक्रोफैराड। एंड कनेक्टिंग 2 in series and 1 in parallel, 2 in series and 1 in parallel, this is the case, then here in this particular case we'll be getting 6 microfarad। So that means this is wrong, this is wrong। and connecting 2 in parallel and 1 in series, दो पैरेलल रहेगा, दो कैपेसिटर्स, 2 कैपेसिटर्स विल बी पैरेलल, एंड आफ्टर दैट 1 in series, that means here 4 plus 4, that is 8, 8 and 4, 8 and 4 in series means 8 into 4 divided by 8 plus 4, so it will be 32 divided by 12, so it will be less than 3। Clear? We will be getting less than 3 microfarad, that means this is also not the case, so that means option C will be the correct one। The equivalent capacitance for the network shown in the figure, so here in this particular case this network shows, then it is asking what will the equivalent capacitance over here। So in this particular case, first of all we'll figure out where the battery or cell is connected। So this is there is a 400 volt battery which is connected to this particular arrangement, so that means over here what will be the directional flow of current? So the directional flow of current will be from the positive terminal to the negative terminal, so as there is a branching over here, so some current will flow over here and remaining current will flow through 100 picofarad capacitor। Clear? So that means this is how the capacitor will get charged, clear, by this 400 volt battery। So as same current will be flowing through both C2 and C3, that means C2 and C3 are in series, C2 and C3 are in series। So if C2 and C3 are in series, that means here in this particular case their equivalent capacitance will be equal to the equivalent between 2 and 3, or you can write 2 and 3, C23, C23 will be how much? It will be 400 plus 400, so that means we'll writing, so equivalent same capacitance है और दो है तो equivalent capacitance कितना होगा? 400 divided by 2। Clear? So it will be how much? 200 picofarads। How we are getting? You can also calculate that one by taking C23 will be equal to C2 into C3, C2 into C3 divided by C2 plus C3, so it is 4 into 4, that means let it 400 into 400 divided by, it will be 800, so it will cut by 2, so it will be 200, so how much we will get? 200, so it is 200 picofarad। Clear? Okay, so right now instead of taking two 400 picofarads, we can take a single one of single one. Here in this particular case we can instead of taking these two here, instead of taking these two, what we can do, we can take a single capacitor, we'll take one single capacitor, a single capacitor here of 200 picofarad. And right now here this 100 and 200 are seems to be in parallel. As these two are in parallel, that means their equivalent capacitance will be how much? That will be 100 plus 200, that means that will be 300 picofarad. Clear? So that means this C1, that means here we can write C1 and C23 are in parallel. C1 and C23 are in parallel. That means their equivalent capacitance will be how much? 300 picofarad. So here finally what we got here in this particular case, if we just remove this particular system over here, clear? Suppose if we remove this particular arrangement, clear? And so finally how much we are getting? We are getting a system of this particular one. So this is 300. This is a 300 picofarad capacitor, and this is a 400 picofarad capacitor, and they are connected to a 400 volt battery. So that means these two are connected in series. Clear? These two are right now connected in series. That means C4 and CP, which is the equivalent capacitance of C1 and C23, are connected in series. If these two are connected in series, then their equivalent capacitance will be how much? So C4 is 400. Here C4 is 400 picofarad and CP is 300 picofarad. So that means it will be how much? So 400 into 300 divided by 400 plus 300 by using the previous formula, C1 C2 divided by C1 plus C2, that formula by applying. So how much will be getting? It will be 12 4 zeros divided by 700. So 2 zeros will get cancelled out, so it will be 1200 divided by 7 picofarad. So the net equivalent capacitance will be how much? 1200 by 7 picofarad. So here in this particular case, option A, 1200 by 7, that is correct. So rest others are wrong. So option A will be the correct one.